Hello students, in this lecture video I will demonstrate how to solve a project scheduling problem. So this problem is coming from chapter 9, project scheduling. Uh, Refer to table number 9.3 on page number 391 and 9.4 on page number 393. So we will use this table. This table will be given, and based on these tables we have to find the expected project time, the project completion time, and other questions, answer for other questions. So this is a table that's given. We have been given the activities here, and we have been given immediate predecessor. So that means, to start activity C we must complete A, to start activity D we must complete A again, and to start activity E we must complete A again. To start activity F, we need to complete activity C before we can start F. Activity A and B, they are the starting activities. They can be started anytime. They don't have any constraints. They don't have any activities prior to them that needs to be completed. So the activities can be started anytime. So we have been given activities and we have been given immediate predecessors, and then these activity times are uncertain. So we have been given optimistic time, most probable time, and pessimistic time. So that means if this data is in weeks, so activity A, the most optimistic time is 4 weeks. If everything goes well, this will be completed in 4 weeks. If nothing goes well, the pessimistic time, it might take 12 weeks. And most probable means, under the normal situation, it should take 5 weeks. So we always have been given these three um times, and based on this data here, we need to find the answers for some questions here. So let's see the first question here. Find the expected time and variance for each activity. Draw the network diagram and show all the calculation using early start, early finish, late start, and slack. All times are in weeks. So we have been given the same data here. So I just duplicated the data here. Now here we will find the expected time, which is given by the formula equals this activity plus 4 times most probable time plus pessimistic time whole divided by 6. And I need to open the parenthesis here. So that should give us 6 weeks. That's the expected time. That's the mean. That's the average expected time for activity A. Likewise, we can calculate the variance for activity A, which is given by, let's say, pessimistic time minus optimistic time divided by 6, and whatever difference or whatever result is there, we have to raise it to the power 2 to get the variance. That's going to be 1.78. Okay, so we can simply select both of them and click this arrow here to fill up the table. So it did all the calculation for expected time and variance for all the activities. Okay, so that's the first thing we need to do to find is to find the expected time and variance. And now what we need to do is we need to draw the network diagram. Now we're gonna follow some notations. So this is the box here. Let's go through this one. ES stands for early start, EF stands for early finish, D stands for duration, LS stands for late start, LF stands for late finish, and S here stands for slack. So the formula for early finish is equal to early start plus duration. So early finish is going to be early start plus duration. And late start will be given by late finish minus duration. And the slack is you subtract EF from LF or ES from LS. Same thing. So it's going to give you the slack. That is allowable slippage. That is how much wiggle room you have to delay the activity without delaying the project completion time. Okay, so we'll go through that one as well. So we're gonna follow this notation. First thing first, we need to draw the network diagram. And what I'm gonna do here, I will simply copy this table here because I'm gonna need that. I'm gonna put it here so that we have things side by side. Okay. Okay, so let's make it a little bigger here. It's gonna expect some room. Okay. Maybe let me copy just few fields at a time. Okay, and I need this to here. Just the one here. Okay, that's gonna be my. Okay, so here I'm just gonna pass on the reference here, and then just, so these are the expected time and these are the activities we're gonna use, and probably we can use it here. So I'm gonna mm, okay, so you can see everything here. Just so for each activity, so let's see how we're going to draw the network diagram first. So activity A and B, they are the starting activities. So we have multiple start here. So activity A and B are the multiple starts here. Uh, so if, when you have multiple starts, or in other words, you have more than one activity in the table that does not have any immediate predecessor, then you have to start with a dummy node. So dummy node gonna have a duration of 0. So this is how we're gonna do that. Dummy node here, and I'm gonna draw two arrows to A and B. Okay. Now CDE follows activity A. So I'm going to draw CDE, which follows A, which means that before I can start CDE, I must complete activity A, right? And then you have F here should follow C, G should follow D, H should follow B and E, which means that before I can start H, I need to make sure activity E and B, they are completed. Okay, so likewise I follows H and J follows F, G, I, which means before I can start J, I need to make sure that activity F, G, and H are completed. Okay, so that's how you would draw the diagram. I just drew the diagram using insert this symbols here. I use oval shape, I use boxes, I use arrows. So I'm gonna leave that up to you. Simple thing, you can figure it out. Okay, so with the diagram already done, we can move our attention to the algorithm. Okay, so the algorithm is going to follow this notation here. So every activity will have that box here, early start, early finish. Every activity will have that box here. So first thing what we're going to do here, we're going to list the duration here. D is the expected time, project expect activity expected time, for which we have done the calculation here. So if you see a dummy activity, S is a dummy activity. It does not have any duration, it does not consume any resources. So we just need this one to complete the diagram. Now you need to understand one thing, that the network diagram starts with one node and ends with one node, and that's the reason we need the starting node here. Okay, and sometimes you might not have been given the end node. In that case, if J is not given, then you're going to complete the diagram putting the end node here. You can call it J, X, Y, Z, whatever you want, but the duration is going to be 0 here. That's just example. Okay, but in this case we have been given J. So for activity S, which is the dummy activity, duration is 0. For activity A, the expected time is 6 here. For activity B, the expected time is 2. For activity C, the expected time is 3. For activity D, the expected time is 5. And for activity E, the expected time is 3, and henceforth. So you're going to list all the duration activities along the path for all the activities. So once we have completed the network diagram, which basically goes from left to right, and we have noted down all the durations, now we can go ahead and perform the calculation using our algorithm that will help us find the project duration or the project completion time. So here is how it goes. In the for we gonna have two passes. One is the forward pass, which goes from left to right, and second is the backward pass, which goes from right to left. So first we're gonna do the forward pass. So in the forward pass, we'll calculate values for ES and EF, and once we are done, we're gonna start our backward pass and do the calculation for LF and LS. So to start with, let's do early start and early finish calculation. To start with, it will always be 0. I'm going to put 0, 0 here. And early finish is simply going to be early start plus duration. Both of them are 0. So that will be again here 0, 0. All right. Now, since this activity early completes on 0 time, that means I can start this activity on 0 time. I can also start this activity on 0 time, because it tells me that as soon as activity S is done, I can start activity A and B, and we know that activity S is a dummy activity. It does not consume any resources, so duration is 0. So if this is done at 0 time, I can start A and B at 0 time. Now early finish for activity A is going to be 0 plus 6, which is 6 here. So I'm going to write 6 here. And for activity B is going to be 0 plus 2, 2 here. So if activity A is completed on 6th week, I can start activity C on 6th. I can start activity D on 6 as well, and activity E on 6 as well, because all of these activities, they are sort of dependent on activity A to be completed before you can start them. So as soon as A is done on 6th, I can start all these 3 activities, C, D, and E on 6th. So early finish for activity C is going to be 6 plus 3 equals 9, and early finish for D is going to be 6 plus 5, 11. And uh, activity E will have early finish time of 6 plus 3 equals 9. Now, since activity C is done on 9th, I mean I can start F on 9th, because once activity C is done, I can immediately start activity F. Likewise, I can start activity G, early start time equals 11, because that's when activity D is completed. Early start time for H is going to be 9. Okay, so early finish for F is going to be 9 plus 2, 11, and early finish for activity G is going to be 11 plus 3, 14, and a early finish for activity H is going to be 9 plus 4, which is 13 here. Not 13. Okay, let me take my sentence back here. Now activity H, if you see carefully, it needs 2 activities to be done before you start H. So you have to make sure that activity is completed and B is also completed. Now B is completing on 2 and E is completing on 9. And that's the reason I could start this on 9th. I should not have put 9 there. Now I can go ahead and put 9 here, because this value will depend on these 2 activities. So what I have to do is I have to take the maximum early finish times for uh, both of these activities and put that here. And the reason being, activity H can only be started once E and B, they both are done. Now if B is done on 2nd week and E is done on 9th week, I cannot start activity H on 2nd week because E is not completed yet. So I need to wait for the E, and once E is done, which is 9th, so I'm going to put 9 here, so I can start H on 9. So while going forward, you always take the maximum of all early finish times. So here we're going to take the maximum of 2 and 9 and put it here. So 9 plus 4, now I can go ahead and put here 13. Okay, hold on. So I'm going to put 13 here. Okay, so that's how I got 13 there. Uh, and now we cannot do activity J because to start activity J, we need to make sure activity F, G, and I, they all are completed, but we have not done yet with I. So has H as immediate predecessor, which means H needs to be completed before we can start I. So the starting time, early start time here is going to be 13. And early finish is going to be 13 plus 2, 15. And now what I need to do is I need to compare the early finish time for I, G, and F and take the maximum. So this is going to be here, maximum of 15, 14, and 11 is 15. So I'm going to put 15 here. Again, why 15? Because I need to make sure all these three activities are done, and then only I can start J, and I is the one that's finishing up on 15, the most delayed activity of the three, and I need to wait for that activity before I can start J. Okay, so again, if I start activity J on 14, that means I is still not done, and basically I cannot start J on 14th. I have to wait for activity I to be completed. So early finish of activity J is going to be 17. Okay, and that 17 is the project completion time. That's how much time on an average project will take to complete. So it's a project completion time or project duration. So once we are done with the forward pass, we can start our backward pass, and backward pass will allow us to find the value for slack. Okay, so what we're gonna do here, so the early finish becomes the late finish for the last activity. So I'm going to put 17, and late start is going to be late finish minus duration. So 17 minus 2 is 15 here. Okay, now since this is starting on 15th, so I can finish activity I on 15th latest, and I can finish activity G on 15th, right, and activity F on 15th. Because if you see, as soon as if I can start G on 15, that means latest I should be done with activities F, G, and I on 15th week. So forward pass is early start, early finish. That means how early you can start the activity and how early you can finish the activity. Backward pass is late start and late finish, how late you can start the activity or how late you can finish the activity. So that's something you have to keep in mind. So here for activity F is going to be 15 minus 2 as 13 here. 15 minus 3 is 12. Okay, and 15 minus 2 is 13 here. Okay, so if this is starting on 13th, I mean I can finish activity H by 13th, and I can latest start time for activity H is going to be 13 minus 4, that's 9, right? So if this is starting on 9th, I can finish this one activity E on 9th, and activity B on 9th also. So that gives me latest start as 9 minus 3, 6 here, and 9 minus 2, 7 here. Okay, so likewise here, latest start here for activity G is 12. So for activity D, latest finish will be 12, and latest start will be 12 minus 5, that is 7. Okay, likewise here for activity C is going to be 13, and late start is going to be 13 minus 3, which is 10 here. Now coming back here, activity Okay, so when should we finish this one? Because if you see, activity C needs to be started on 10th, D needs to be started on 7th, late start, and activity E needs to be late started on 6th week. Okay, so which one should we take? Should we take 6? Should we take 7? Should we take 10? Now let's say if we take 10 here, okay, if you take 10 here, that means I cannot start activity E on 6th, right? It does not make sense because this activity, I can only start E after activity A is done, right? So likewise, 7 not gonna work. So basically I must uh, finish activity A by 6th so that I can start activity E on 6th. And then you can always start activity D on 7th and C on 10th. So while going back, you take the minimum of all the late start times of the involved activities. Okay, so it's going to be minimum of 10, 7, and 6, and we're going to put 6 here. So likewise here, right? So we're going to do the same thing. But let's calculate late start here for activity A, which is going to be 6 minus 6, 0. Okay, and we already calculated the late start time for activity 7 here. Okay, so for the dummy activity again is going to be the minimum of late start of activity A and late start of activity B, which is 0. So it's going to be 0 here, and 0 minus 0, late start is going to be 0. So that's something you have to keep in mind. Dummy activity, start activity will have everything as zeros when you're done with the algorithm. Okay, so now we have calculated the algorithm. We have found out the expected project duration, which is 17 weeks here. Okay, uh, what we need to do here is we also need to find the slack. Okay, so let me check on that one. Okay, so simply what I can do here, I can draw a box here because that's a box here, right? So I can just copy this one and put it here. Okay, okay, I'm gonna right click here. First of all, I'm gonna change the font color, right click it, format shape, and I'm gonna say no fill. Okay, and slack is basically given by, as we saw, late finish minus early finish, or late start minus early start. So here is going to be 13 minus 9 or 10 minus 6, which is 4. Okay, right, so I can do a little here. That's a slack. That's how much sleepage I have. That means I can delay activity C by 4 days and still will be able to complete my project on 17th week. That's how you would do it. I'm going to copy this one, put it here, because I'm going to need that everywhere. Okay, okay, let's put it here. Let's put it here. Let's put it here. Okay, so okay, so let's do one at a time. So here 15 minus 11 is again 4. 17 minus 17 is 0. That's my slack here. uh, Here 15 minus 14 is 1, so slack is 1 here. 15 minus let's say here 15 minus 15 is 0, right? 13 minus 13 here, or 9 minus 9 is 0, right? And this one is 9 minus 9, or 6 minus 6 is 0 here. Okay, and 12 minus 11, or 7 minus 6 is 1 here. Okay, and this is going to be 6 minus 6, or 0 minus 0 is 0 here. So here also we're gonna have slack of 0. Okay, and we need one more. Let's put it here. 9 minus 2, which is slack of, 9 minus 2 is a slack of 7, or 7 minus 0 is 7. So that's a slack, that's allowable slippage that you have, which means I can delay activity D by 1 day without affecting my project duration. I can delay activity by G by 1. I can delay activity F by 4 weeks. Still will be able to complete project on 17 week. That's something you have to keep in mind. So we have calculated the project duration, we have calculated the slack. Now we have to identify the critical path. Now the critical path will be given by all the critical activities, and critical activities are the activities that have zero slack. That means you cannot delay those activities. Delaying critical activities will delay the project duration. So here what we're going to do here, we're going to connect all the activities that have zero slacks. So let's this one. So what I'm gonna do here, just to make it more visible, so I'm gonna increase the, let's say 2, and make it like a different color. Okay, so maybe increase it more. Okay, so I'm gonna format this one and connect all the activities with zero slack. So activity A has zero slack, activity E has zero slack, activity H has zero slack, I has zero slack, and J has zero slack. Okay, so that's your critical path. So critical path becomes a S A E H I J. That's your critical path, and we already know the project duration. So if you sum up the duration for all the critical paths, you will get the project duration. So it's going to be 6 plus 3 equals 9, plus 4 equals 13, plus 2 equals 15, plus 2 here equals 17. Okay, that's your project duration. So let's go back to the second question here. The first question we answered it. We found out the critical path, we found out the project completion time, and also now did all the algorithm here, which includes calculation for early start, early finish, late start, and slack. Now here, second question here is identify the critical path by highlighting and find out the project estimated completion time and standard deviation. So we already found out the project completion time, which is basically the sum of the duration of all the critical activities. And what we can do here is, in this table we can highlight those activities. So we have A activities, and then you have E, and then you have H, I, and J. Okay, so what I'm gonna do here, I'm gonna just highlight with a different color, something like this. Okay, so these are my critical activities, and I have written here. Okay, this color indicates critical activities. Now going back here, project duration is gonna be the sum of all the critical activities, expected time of critical activities. So this comma, this comma, 4 comma 2 comma 2. Okay, and we know that it's going to be 17 weeks. Okay, now we also need to find the standard deviation of the project, which is given by the square root of summation of variances of all critical activities. So that's going to be equals to SQRT square root of, I'm going to say sum, and I'm going to go here, I will select 1.78 comma 0.11 comma 0.69 comma 0.03 comma 0.11. Okay, so that's for the sum and that's for the square root, and this should give us 1.6499. So I'm just gonna cross check that number here. Yes, that's what I got here. So that's a standard deviation of the project duration, okay, in weeks. Now the project duration or the project completion time follows a normal distribution, and uh, that's something you have to keep in mind, with the mean of 17 weeks and standard deviation of 1.65 weeks. Okay, in this case. Okay, so the project duration is always assumed to follow normal distribution given we have a large number of critical activities involved. So summation of the times of all the critical activities follows a normal distribution. So to cut it short, project completion time, which is the summation of all the critical activities, will always follow a normal distribution with the mean expected time of 17 weeks and the standard deviation of 1.65 in this case. And these figures will change for a different problem. Okay. So that's something you have to calculate here for the B. For the C, we need to find out the probability. What is the probability that the project can be completed in 20 or fewer weeks? Okay, this is denoted by like the probability of T being the time less than equal to 20 weeks. Okay, so now we know that it follows a normal distribution. So we need to find the value of Z. Okay, so we're gonna find the value of Z, and that will give us the probability. Okay, we're going to find the probability using normal distribution table. Okay, so let's find the value of Z here, which is given by the desired time minus expected project completion time, the whole divided by standard deviation of the project completion time. So the desired time is 20 weeks minus 17 is our expected time, divided by the whole divided by 1.65, which is the standard deviation that we got. So here we can do the calculation here, not here, here. So 20 minus 17 whole divided by 1.65. Okay, so that's going to give us Z value of 1.818 or 1.82 roughly. So from the normal distribution, we need to find the area under the curve, which is approximately 0.9656. And that tells me that there is 96.56% probability that the project will be completed before 20 weeks deadline. So what is the probability that, basically this is the same as asking what are the chances that the project will be completed within 20 weeks. Within 20 weeks means it can take anywhere from 0 to 20 weeks. Okay, now let's go back to normal distribution table and see how this thing works out. Okay, so I'm going to open here. I just want to make sure I'm sharing my screen here. So I'm gonna go to images.google. Okay. So I'm gonna say normal distribution curve to start with. Now the normal distribution curve looks like this. Okay, as you can see here, we have a standard normal distribution curve with the mean of 0 and a standard deviation of 1. Okay, so within plus and the values that you see on the x-axis, they are the Z values. So within plus minus 1 Z value, you have 68.3% area under the curve. Within minus 3 and plus 3, you have almost 99.7% of the area under the curve. Uh, so the total area under the curve is 100% or 1, you can say that. Okay, and then rest you can figure it out. Now why we use this thing? Okay, why use normal distribution? Because normal distribution will help us find out the probability of completing the project on time if we know that the project completion time follows normal distribution. Okay, now as I said, the mean of this distribution is in our case 17 weeks. Okay, so that means on an average it takes 17 weeks to complete the project. And the area under the curve towards the, if you see the left side of the 0 and right side of the 0, it's perfect symmetry. That means you have 50% of the area on the left side and 50% of the area on the right side. Okay, which means that area under the curve tells me the probability, which means that if you take 17 weeks and if I ask you, okay, what is the probability that the project will be done on within 17th week, you have 50% chance, because that's our shaded area here from left to up to 0 here. Okay, that's your shaded area. Okay, So when you say that you want to find out the chances that the project will be done within 20 weeks, I know that 17 is the mean, and we are going towards right side of the mean, which is 17, somewhere here, whatever it is. Okay, so that tells me that it has to be more than 50%. Okay, because we are going to the right side of the mean. Okay, up to the mean we have 50%, and then we're gonna keep increasing towards 100% as you move from left to right. So that's something you have to keep in mind. So let's go back to the normal distribution table. Okay, so we just calculated the z value of 1.81. Okay, so 1.81, we're gonna use this table here. See, it tells me that it is more than half. Okay, 1.81. If the z value is positive, you're going to use this table. Okay, which tells me that it is more than 50%, because it is more than half of the curve. Okay, so 1.82 is going to be 1.82 roughly is going to be 0.9656 here. So 1.8, and you add 0.02 to it. That's how you make z value of 1.82, and you go here and find this value here. Okay, 0.9656, and that's what we got here, 0.9656. So that tells me that if this is roughly, you can consider, let's say if this z value here is 1.82, which is roughly here, right? 1.82 here. That means I'm going to shade all the area from the left up to 1.82, which tells me that I'm 96.56% sure that the project will be done within 20 weeks. Now you can flip the coin and ask another question. So like, what is the probability that the project will take more than 20 weeks? Okay, so that means we are trying to find the area under the curve, where you see this white area. So this white area will sort of tell us that the probability the project is going to be completed, or will take more than 20 weeks. Okay, so for that, we know that how much time is going to take less than equal to 20 weeks, and we know that the area under the curve equals to 1. So if we subtract our 0.9656 from 1, we get the probability of project completing or taking more than 20 weeks. Okay, please see the symbol very carefully. Okay, when we are talking about the less than, we are always talking about less than equal to, which means including 20 weeks. Okay, when we talk about greater than, we talk about greater than. We are not putting any equal to sign there. Okay, because equal to sign is already put in the less than equal to constraint here. So that's something you have to keep in mind. So here 1 minus 0.9656, that's going to give me 0.0344, which means that there is only 3.4% chance that the project will take longer than 20 weeks. So it's a very slim chance. Okay, so we are almost again 96.56% sure that the project will be done within 20 weeks. If I ask you, okay, what are the chances that the project will be done within 17 weeks? So I guess I answered that before, right? 17 is the expected time, the mean of the distribution, and the area under the curve up to the mean is 50%. So there is only 50% chance that the project will be done within 17 weeks. Okay, so as you go lower, the chances of completing the project gonna get lesser and lesser. Okay, so if you say, okay, so here, what is the probability that the project can be completed within 15 weeks? Okay, which is denoted by a project completion time taking less than equal to 15 weeks. Okay, which means that you're going to the left of the curve, right? You're going to the left of the curve. So probably I'm going to use this one. This tells me up to the 0 probability. So basically 0 is our 17 here, and z value here is 15. Okay, so we know that up to 17 we take 50%. It's a 50% chance. So anything less than 17 has to be less than 50%. Okay, and that's what you need to sort of do the brief mental checkup here. Okay, so we need to find the z value here, so we can subtract the expected time from the desired time, and the whole divided by the project standard deviation of 1.65. So here is going to be 15 minus 17 whole divided by 1.65 here. So it's going to give me negative minus 1.21. Okay, so if you go here, anything towards the left side of the zero will always be negative. Okay, because we are getting lesser and lesser. Z value always goes from basically if you see normal distribution curve, again Z value always goes positive towards the right side and negative towards the left side. So we go -3 to +3 range. Okay, now in this case we have a Z value of 1.21. So -1.21 is this one. So -1.21 is going to be 0.1131. That's what we got, 0.1131 here. Okay, so what is the probability that your project will be completed within 15 weeks? It's equal to 0.1131, which is equals to 11.31%. So we can say that so there is 11.3% chance that the project will be completed within 15 weeks. So as you see, it's lower than 17 weeks, right? 17 weeks was 50%, 15 weeks is going to be 11%, 20 weeks is going to be 96%. So something you have to keep in mind. Okay, and obviously chances are very slim that it's going to be completed within 15 weeks. And if you flip the coin and ask what is the probability that the project will be or will take more than 15 weeks, which is probability of t greater than 15. So we already calculated less than equal to 15 probability. If you subtract that one from the one, you get the probability of completing the project or taking more than 15 weeks here. So 1 minus 0.1131 here. So 88.69%. So it's like very high chances. The probability is very high that the project will take more than 15 weeks to complete. 88% chance. So that's something you have to keep in mind. So this is how you would solve the project scheduling problem. I hope this was helpful. Thank you very much for watching the video.